Hello, good evening, Rishika. Welcome to the class. How are you? So today we are going to do 9IC, right? We have done A and B. Today we go to C, which talks about voltage and energy. So till now we have been studying about energy. We have been studying about the transfer of energy. We have studied about the law of conservation of energy. Okay, we have learned about the transformation of energy. Now today we study the electrical energy which comes to our house. Okay, they have terms related to them like voltage. Okay, and of course they transfer energy to your houses. Good, nice to learn that you are in good shape, keeping at home. You had a test today. You didn't attempt it. Scared of the test? I'm giving you all similar questions. Okay, what I had given in the previous class because I want to check. We have now discussed the questions. Now I want to see how you answer them. So there will be similar kind of questions which you had got in the previous test. Don't be scared of the test, right? Okay. Now you need to tell me what is the voltage of the electric current supplied to your house. What is the voltage? You are busy. Okay. Now tell me what's the voltage of the electric current which is supplied to your house? Then we go and find out how our voltage and energy linked, right? So now we know that electricity is a way of transferring energy. Okay, it's a way of transferring energy, and we can change it into all different forms as per our need. If I want to make a toast, okay, I turn electrical energy into heat energy, and my toast is made. If I want to enjoy cool air, I turn electrical energy into mechanical energy of the fans of a blade, and they rotate and give me cool air. If I want, again, I use, in most of the forms, I use it in mechanical energy. If I'm pumping water up the tank, I'm converting electrical energy into mechanical energy, right? 220 volts. Okay. Your book says that the energy supplied is at 230 volts. Okay. In India also it's 220 volts. Okay. So the energy which comes to your house comes at 220 volts. How does electric current flow? How does electric current flow? That we have already understood. Okay. Uh, and I'll just take you there. Okay. Just a minute. So let's draw a conductor first. Okay. A conductor is made up of a metal. Metal's a good conductor. You know that, right? So I have a conductor which is made up of metal. A metal. Okay, now this metal will be having many atoms inside it, right? Because after all, a metal will be made up of atoms. So we say that there are many atoms inside this metal. You also know that it's composed of many atoms. Okay, now these pink things are atoms. Okay, now for something to behave as a good conductor, it should have free electrons. Okay, the atoms, you know that they are made up of these protons, neutrons, and electrons. Okay, so what these do, these release, I mean, some of the electrons, okay, the red ones which I'm making, they move out of the atoms. Okay, and they are moving haphazardly inside a conductor. Okay, this is it is these electrons, it is the presence of these electrons because of which a conductor is actually able to conduct electricity. Okay, these are known as free electrons. These are known as free electrons. Okay, and when I apply a voltage across them, now they are moving haphazardly. Okay, this one may be coming this side, this one may be going that side, this one may be going this. So they are moving in any direction. They are moving haphazardly because at present we don't have a voltage across it. We don't have a potential difference applied across the conductor. So there is no flow of electrons. They're not drifting in a fixed direction. Okay, as soon as I apply a voltage, okay, as soon as I apply a voltage, then what happens that they start drifting. Okay, now they start moving. Now the electrons, they are moving. Okay, now the electrons are moving. They inside the conductor. I'm showing it to you outside. Okay, they start moving from a low potential to a high potential. Okay, so what does this voltage do? This, now if I have to do any work, I'll need energy, right? Yes or no? If I need to do anything, I need to have energy in me. Okay, so if any work is to be done, I need to spend energy. Similarly, if these electrons need to move, which means they'll be doing work. Okay, so if they are doing work, they will need energy. Okay, so this energy is supplied to them. This potential difference is created by something known as a cell or a battery, or like in our house it comes from the mains, like in Gabon you get 220-volt supply. Okay, uh, okay, you have written 50 hertz also. What do you mean by 50 hertz? Are you aware? 220 volts, so I'm explaining its voltage. I'll explain it to you nicely today. You also have written 50 hertz. Do you know what does 50 hertz mean? What does 50 hertz mean? If you know, good. If you don't know, say I don't know. I'll explain it to you. Don't you worry. Waiting for your answer. What you have written is absolutely correct. Okay, you've written 220 volts and 50 hertz. What is 50 hertz? No? Very nice. 50 cycles per second. Very nice. 50 cycles. Okay. You know, you're a smart girl. That was absolutely the correct answer. Okay. Now, the current which comes to your house is known as AC current. It's known as alternating current. Okay, which means this current changes direction. Okay, for some time it was flowing in one direction, and then it starts flowing in the other direction, then again it starts flowing in the initial direction, and again it starts flowing in the reverse direction. So this graph shows the direction. Okay, and the current is increasing, then the current drops, then the current again starts increasing in the opposite direction, it again starts decreasing. Okay, so from this point to this point, it starts from this place. Where is my cursor gone? Okay, it starts from this place and it finishes at this place. This complete is one oscillation. Okay, it goes to the other side, comes back to the initial position, goes to the other side, then comes back to its initial position. So this is one complete cycle. So 50 hertz, like you said, means that the current that comes to our house, it oscillates 50 times. It has 50 cycles. It oscillates 50 times in 1 second, right? We go back now to the book and we discuss a little over there. Then we'll come back over here. Okay. So now we have understood that an electric current is a flow of tiny particles called electrons. You have understood that the electrons drift once we create the potential difference or once we supply the voltage. Okay, electric circuit has something to push the electrons. I've already told you what is there to push the electrons. I either, in case of a direct current, I have a cell or a battery, and in case of a alternating current, the voltage is supplied to me through the power mains, the power pack. Okay, a complete circuit for the current to flow around. I have to have a complete circuit. If there's a break, then the current doesn't flow. Components like the bulb or the buzzer that transfer energy as light or sound. Okay, now we go back to the Creta screen and we discuss all this over there. Okay, so now they say that there has to be a supply. Okay, I have to have a complete circuit. If I use a cell, I draw something like this, a long line with a short line, okay, showing that this in this circuit, a DC current is flowing. Okay, this is a plug-in key, and then I have an appliance. I can place a bulb. We make a bulb like this in the circuit. Okay, so this is the positive, this is the negative, and this is a complete circuit. So I need something to supply the energy to the electrons to flow. The electrons will be flowing from this direction, okay, and the current conventionally we take to be opposite to the direction of flow of electrons. So my electric current will flow from the positive to the negative, whereas my electrons will flow from the negative of the cell towards the positive. Got it? Now this circuit is complete and it has a load in it. Now what does this load do? Okay. Now this battery or cell, okay, is giving the energy to the electrons. So the electrons with high energy, they start traveling in this conductor. Okay, they are coming like this. Okay. And now when they cross through the bulb takes up the energy. Okay, it uses up the energy, and what does it do? It converts that energy into light energy. Okay, some of the energy is wasted in the form of heat energy, and some of it is converted in the form of light energy. So my energy is changing from one form to the other. Now the electrons which come across the bulb, these have lesser energy, isn't it? Because the energy they were carrying has been used up by the bulb. So now these electrons with lesser energy, now they come back to the positive terminal of the cell. And now the cell again gives them energy, chemical energy is converted into electrical energy, and it is again pushed. Okay, so once again they start rotating. So this cell maintains a constant voltage so that a constant current keeps on flowing and the bulb keeps on glowing. Understood? Yes, no, tell me. Okay, and then we'll move forward. Okay, so now if it's a bulb, it will convert it into light energy. If I have a buzzer, okay, if I have a buzzer like this, okay, then what the buzzer does, the buzzer uses the energy to change it into sound energy. Okay, similarly a fan changes it into mechanical energy, a bell changes it into sound energy, a oven changes it into heat energy. Okay, so there are numerous appliances in your house which run on electricity. So once we have the voltage which is meant to be in which this appliance need to be operated, once I've connected that, then the required amount of current starts flowing in the appliance and the electrical energy gets converted into whatever form of energy I want it to give it to me. Okay, we go back now. So we have understood I'll ask you these things, okay? An electric circuit has something to push the electrons is the first point. What's that thing which is used to push the electrons? It's a cell or it's a main power supply. Then the second point is that we should have a complete circuit, which I drew and I've shown it to you. And the third thing, for the transfer of energy, I need a load. Okay, I mean need an appliance like a bulb or a buzzer or an oven or an heater or a toaster or a fan, anything. Okay, so I need a component that transfers energy. Got it? Now, how do we measure this? I'll go back now. How do we measure this? We go back. Okay. Now, what is current? Okay. What is electric current? Electric current is the flow of charge. Okay. I told you that the electrons are flowing. Okay. Which means charge is flowing. So we represent electric current by an I. Okay, and this is equal to, what is electric current? Electric current is the rate of flow of charge. Now we represent charge by Q. So suppose Q is the charge that has flown through the cross section of a conductor in time t. Okay, then what is the current that has flown through the conductor? We say current I is equal to Q by T, where Q is the charge that has flown through the conductor in time t. Am I clear? Right? So we measure it in a unit known as ampere. Okay, in honor of a French scientist, Andre Ampere. We measure its unit is ampere. Okay, and 1 ampere. How much is 1 ampere equal to? The unit of charge is coulomb, and you know that the unit of time is second. Okay, so if through the cross section of a conductor 1 coulomb charge is flowing every second, okay, we say that the current that is flowing through the conductor is 1 ampere. Simple, understood? If 1 coulomb charge flows through the conductor every second, we say that the current that has flown is 1 ampere. What is the instrument which we use to measure current? Uh, the instrument which we use to measure current is known as an ammeter. Okay, it's known as an ammeter. Okay, sorry. Uh, Okay, understood this much. Now, how do we connect it? Now, this was the circuit. Okay, suppose I want to know how much current is flowing through it. So, I always connect it in series. Okay, so I have connected it in series with a bulb, ensuring that the positive of the ammeter is connected with the positive terminal of the cell, and the negative is connected with the negative terminal of the cell. Right? Understood, beta? So an ammeter is an instrument which is used to measure current which is flowing in a circuit. It is always connected in series. Okay, and we have smaller units also. This is the ammeter. We have smaller units also. If I have small quantities of current which need to be measured, okay, then I use smaller units, and some of the smaller units are, one is milliampere, which I write a small m followed by the ampere A. Okay, and this is known as milliampere. Okay, and what is the relation between milliampere and ampere? 1 milliampere is equal to 10 to the power minus 3 amperes. Okay, which means it is equal to 1 divided by 1000 amperes. So what is milliampere? Milliampere is 1000th part of an ampere, right? Similarly, to measure even smaller currents, we use microampere. Okay, and how much is microampere equal to? Microampere is equal to 10 to the power minus 6 amperes. Okay, we go back now to your book. Now that you have understood how to measure current, okay, how to connect it. Uh, Next, we go to, so you can see the units are amps. We call it amps or ampere, and you present it by a capital A. The instrument used to measure electric current is ammeter. Right? You can see the cursor over there. So this is an ammeter, which is always to be connected in series. Okay, and the unit in which current is measured is amps, which we represent via capital A. Now, what is voltage? The chapter, the unit's name was voltage. So now we go to voltage. What is voltage? The voltage of a cell is a way of measuring how much energy the cell gives to the current. Okay, the voltage of a cell can be measured using a voltmeter, and the unit of voltage are volts. We go back to the Krita scheme and we understand this. Okay, now suppose. Okay, now suppose I draw the diagram once again, all over again. So I have a circuit, I have this bulb over here, and I have an ammeter connected in series. I have a switch, okay, and I have a cell which is giving energy to the charge, and the charge is flowing. Okay, I suppose I say that this gives a potential difference of 6 volts. It creates a potential difference of 6 volts. Okay, which means from this point, to this point, okay, the difference between the potentials is 6 volts. Okay, which means we know that uh, we know that what is potential. Potential is the work done in moving. What is potential difference? It is the work done in moving a unit charge from one point to the other. Okay, so if I go by that definition, okay, it means 6 volt, okay, is equal to, for unit charge it becomes 1, okay, the work done, okay, which means that 6 joules of work is done. 6 joules is of work is done for transferring 1 coulomb of charge from point A to point B. Got it? Which means this is the energy which has been spent. Got it? So whatever energy, now there's a difference between these 2 points. So this 6 joules energy, the electron, when it was at this point, it had 6 joules of energy, and now when it goes to point B, that 6 joules of energy has been spent. The energy is lesser by 6 joules. So where did that 6 joules energy go? That 6 joules energy is now converted into heat energy and light energy. Understood? Yes or no? Okay. And how do we measure it now? Now, how do I measure what is the voltage across the bulb? So I always connect, I'll change the color, I'll make it green again. I always measure the potential difference across 2 points using an instrument known as a voltmeter. Okay, in honor of Italian scientist Alessandro Volta, we have named the unit of potential difference volt. Okay, so the instrument used to measure the potential difference is a voltmeter, and it is always connected in parallel. You can see that the bulb also is connected to this point, and the voltmeter also is connected to the same point. On the other side also, the bulb and the voltmeter, they are connected to the same point. So when they are connected to the same point, then we say that these two are in parallel. On the other hand, you can see that this is connected to a different point, and the ammeter is connected to a different point, isn't it? It is connected to the other point of the bulb. So when it is like this, then they are in series. When they are connected one after the another, they are known as connected in series. Whereas if they are connected, all of them are connected to the same point, then we say that they are connected in parallel. So a voltmeter is always connected in parallel to measure the potential difference across the instrument. Clear, beta? Write something so that I know that you have understood. Yes, yes, yes. Something more. Now we'll discuss some questions. So the first question which you have to answer is, what are the units of voltage? Answer that and we proceed further. What are the units of voltage? I've explained it to you, Ishika, now, and now you can write it to me and then we proceed. What are the units of voltage? No, just writing a yes won't do. You have to write to me. What are the units of voltage? We just discussed it. Units of voltage. Quickly, what are the units of voltage? The question is on your screen, the yellow box. It's there in your book also. What are the units of voltage? We just discussed it also. We discussed what is voltage, what it does, what is its unit, in honor of which scientist, how we measure it. There it comes. Uh-huh. You have given me all the answers. You have given me answer to voltage, you have given me answer to current, and you have given me answer to ampere. Oh, sorry, resistance. Okay. I wanted only for voltage. So the first one which you have written, the volt, is correct. Okay. Volt, which we represent by a V, is the unit of voltage. And before that, we had discussed the unit of current, and the unit of current is the second one, ampere, which we represent, which we also say amps, and is represented by a capital A. And at present, we haven't discussed resistance. The unit of resistance is ohms. Okay, we move forward now. Okay. Now, there are different ways of increasing the voltage in a circuit. The two ways. The first way is by using more number of cells, and the second way is by using cell that has a higher voltage. Okay, now what happens if you increase the voltage? If you increase the voltage, then keeping other things the same, then the current increases in the circuit. And number two, the amount of energy transferred by each ampere of current increases. Let's go to the Krita screen back again and discuss it. Okay, and then I come back and I'll ask you a few things. Okay, so now this is the circuit. Suppose I say that this is a cell of 6 volts. You can see that two lines like this means a cell. Okay, means a cell. The longer line indicates positive terminal, and the shorter line indicates negative terminal. So if it's just two lines, a long and a short one in the circuit diagram, then it's showing a cell. Now suppose that I have more than two lines. I have four lines like this, okay, and the smaller one is joined to the longer one like this. Okay, then this becomes a battery. Okay, a combination of cells becomes a battery. Okay, which means I have two cells in this, so it has become a battery. Got it? So how can I increase the voltage? The first thing which I can do is I can add one more cell. Okay, so now I've got two cells, 6 volts and 6 volts. So now the total voltage which I am supplying has gone up. It has become 12 volts because I've connected two cells of 6 volts each. Okay, so now I have a battery which is supplying me 12 volts, a higher voltage. Got it? The other way of doing it, I replace this cell and I bring in a cell of 8 volts. Okay, I bring in a cell of 8 volts instead of a 6 volt cell. Now I have attached a 8 volt cell. Okay, so in both the cases I have been able to increase the voltage. The first case, I added one more cell and the voltage increased. In the second case, I replaced my earlier cell, which was of 6 volts, with another cell which was of a greater voltage of 8 volts. Okay, so now when I increase the voltage, what happens? Okay, so now I am giving more amount of energy. Okay, earlier the energy which they could spend, since the potential difference between the 2 points was 6 volts, so the energy that could be spent was 6 joules. Okay, now the energy that can be transferred has become 12 joules because now the charge is coming up with greater energy. Okay, so greater energy can be spent. So now the bulb will give me more light. It will glow brighter, right? Okay, now I look at the ammeter and what do I see? 6, and suppose I take resistance 1, okay, 2, 3. Suppose that the current flowing in the first case, I'll have to make it green there. Okay, suppose the current flowing in the first case was 3 amperes. My ammeter was showing a reading of 3 amperes. Okay, now when I look at the ammeter after connecting one more cell, now I see that a current of 6 amperes is flowing through it. Okay, in case 1 it was 1 ampere, and now when I have increased the voltage, I see a current of 6 amperes being indicated by my ammeter. Got it? So what have I learned? I learned that when I increase the voltage, the amount of current flowing in the circuit increases. That's the first thing. Greater the voltage, greater the current flowing. Okay. What do I learn next? Next, I learned that earlier the energy supplied by, okay, earlier by each charge, okay, was 6 joules, and now that energy supplied has gone up to 12 joules. Okay, so when I step up the voltage, I am also stepping up the energy that is transferred. So two things happen if I step up the voltage. The first thing that happens is that the current in the circuit increases, and the second thing that happens is that the energy transferred by each coulomb of charge increases now. Got it? We go back now and I ask you the questions as I had told you. So now we go to this yellow box, the box on your screen at the top, question number 2. And now you tell me the answers to these, okay? And the first question is, write down 2 ways to increase the voltage supplied to a circuit. You know them, we spent quite some time discussing this with the figure. So first you write me the answer to the second question, which is write 2 ways to increase the voltage supplied to a circuit. And then immediately after that, you can write me answer to question number 3, which is how does an increased voltage affect the circuit? We discussed both the points thoroughly in our discussion. So I am expecting good answers from you. Waiting for your answer, huh? Question number 2, write down 2 ways to increase the voltage supplied to a circuit. And question number 3, how does an increased voltage affect the circuit? And Rishika, my smart girl, is going to give me smart answers quickly. Be quick. I want to finish this question today. Also, do you, celebrate Independence Day there in Gabon also? I mean, the Indian community. Do they do something there on Independence Day? And if yes, did they do it this year? Okay, there comes your answer, and it says, why did you write the Ohm's law? I didn't ask you the Ohm's law. I asked you how can the voltage be increased? Whatever we discussed just a few minutes back. How can the voltage be increased? Quickly tell me. What did I tell you? Two things I did now. The first case, what did I do? I'll take you back to the diagrams and then maybe you'll recollect. Okay, here you see. Okay, I'll focus. Okay, many happy returns of the day, belated happy birthday. You should have told that earlier. Okay, so a gift from our side, no test today. Okay, and when you come down to India, you tell us, we'll get you some nice gift then. Belated happy birthday. So I'm not gonna bother you now, okay? A birthday gift for you today. Not ask you many questions. I tell you, point out, okay? I just pointing out with a red pen. You can focus over there, and you'll tell me. This is the first point, the one underlined with red. What have we done here to increase the voltage? Okay. What have we done here to increase the voltage? The portion where I have underlined with red, you can see that portion of the diagram will bring back everything which we discussed. You can answer me. No? Should I tell you once again? Okay. I asked you that in this discussion, which you see on your screen, okay, I increased the voltage and I have done it in two ways. Okay. The first I have underlined with a red line, and the second case I have underlined with a purple line. Okay, these are the two ways. The red and the purple are the two ways in which I can increase the voltage in a circuit. So can you tell me what are these two ways of increasing voltage in the circuit? What are the two ways that we discussed in which the voltage in a circuit can be increased or changed? How can we change the voltage in a circuit? Okay, I'll tell you the answer. The red portion says by adding cells, okay? By adding more number of cells. Okay, you can see that initially I had just one cell and then I added one more. So 6 plus 6 became 12. So here I have added more number of cells. And what did I do here? I replaced the earlier cell with a cell of greater voltage. Okay, you can see that the earlier cell was of 6 volts and now I have replaced it by a 8-volt cell. So the two ways by which I can change the voltage in a circuit is by adding more number of cells or by replacing the earlier cell with a cell of greater voltage. Understood, beta? If you have understood only then you tell me yes, okay? I show it in your book also where it is, okay? Uh, Here we have it, okay, where my mouse is moving. Using more cells. You can see my mouse moving by using more cells in series. So we had added a 6-volt cell to another 6-volt cell in series in the circuit in the first case where I underlined it with red. Okay. And the second one where I underlined with purple by using cells that supply a higher voltage. Understood? No, you didn't understand. Okay, I'll repeat it once again. I'll take you to the Krita screen. Okay. Now this is my circuit, okay? This is my circuit. I have a bulb in the circuit. I have an ammeter in series. then I have a switch in place, and I have a cell in place. Got it? So now this is a 6-volt cell, suppose. Okay, and I want to supply more. So what do? I well, the first thing which I do is that I don't change anything else. Okay, the ammeter is still there, the bulb is still there, the switch is still there, but I change. What change do I do? Now I put in two cells. Okay, earlier there was one cell, and I connect these cells in series. So this is 6 volts, and plus this is 6 volts. So now the total voltage has gone up to 12 volts. What I have done? Added cells in series. Okay, earlier I had one, you can see over here. Okay, I have only one over here, and bottom over here you can see I've got two. I'll encircle them with red. Okay, you can see that here I have only one cell, and here you can see I've got two cells. Okay, so the first thing which I can do to increase the voltage is add more number of cells in series. Am I clear? Have you understood the first thing? The first way of increasing voltage is adding more number of cells in series. Understood, Rishika? Tell me quickly so that I can go on to the next point. What happened? You become tired or what? Okay, understood. Very nice. So we go to the second step. Okay, this was the first step, and now we go to the second method. I'm so sorry, I said step. Go to the second method. Okay, I changed the color so that you know what are we doing here. This time I take light blue. Okay, this is the second method. I don't change anything else. I keep the bulb as such. I keep the ammeter as such. Okay, I keep the switch as such, but I change. What do I change? I change the cell. Okay, I have just one cell. Okay, but that was of 6 volts, and now this is of 10 volts. Okay, so what have I done? I have changed the cell. I have brought in a cell of greater voltage. I have brought in a cell of greater voltage. So this is the second method. Okay, this is the second method. I can increase the voltage in the circuit by using by using a cell, a cell of greater voltage. So this is the second method. Understood? The first method is I put in more cells in series, and the second method is I replace the cell with a greater voltage. Okay, very nice. Now that you have understood, we proceed further. Okay, we go back to your book and we see what else is there. Okay. So we have also understood now the two things that happens. Okay, the two things which happen when I increase the voltage. The first one is that the current in the circuit increases. You had seen in the diagram. Okay, you had seen in the diagram that the current increases here. Okay, at this position, the ammeter was showing a reading of 3 amperes. But when I double the voltage, now it is showing me a current of 6 amperes. Okay, so the first effect which comes is that the current I increases. Okay, you can see here it is 3 amperes and here it is 6 amperes. So the first change that comes on changing the voltage is when I increase the voltage, the current in the circuit increases. Am I clear? Am I clear, Rishika? Okay, yes, then we proceed further. The second change that comes is that the energy, when I increase the voltage, the energy increases. Okay, so the energy that can be used by the appliance goes up. Got it? Earlier, the appliance could spend just 6 joules of energy, and now the appliance, because of the increased voltage, can spend 12 joules of energy. Got it? We go back to your book and have a look. Okay, so here you can see at the bottom of the page, okay, the first thing where my mouse is moving, okay, here. The first thing, the current increases. We saw that the current increased in our example from 3 amperes to 6 amperes. It became double when we doubled the voltage, right? So the first thing that happens when we increase the voltage is that the current increases in the circuit. Okay, and the second thing that we saw is that the amount of energy transferred. In the first case, the energy transferred was 6 joules, but in the second case, it doubled when we doubled the voltage. It became 12 volts, right? So if I ask you, what are the two things that happen to the current when the voltage is increased? So then you have to reply that, sir, when the voltage is increased, then the first thing that happens to the current is that the current also increases. And the second thing that happens is that the energy supplied or transferred by each ampere of current also goes up when the voltage is increased. Clear? Give me a yes now. If you have understood this, we move further. I'll bring in a similar, okay, example to show this to you how this actually happens. But that's the last thing we'll be doing today, okay? I wanted to finish this unit. I don't think so I'll be able to do it because just 7, 8 minutes more, okay? So don't worry. We'll continue from here in the next class. Understanding is more important. I'm sure you must have understood now. Okay, now we go forward. Okay, now you have this diagram, drawing C. Okay, in this diagram, what do you see? You see a boiler and a pump and some connecting pipes and a radiator. So we discuss this going to the Krita screen. Okay, here we are on to the Krita. We move down and there we redraw the diagram. Okay, so I have a boiler here. Okay, I'll make it in the form of a cylinder. I love cylindrical boilers, so I make it in the form of a cylinder. Right on top of it, boiler. So in a boiler, we are boiling water, okay? And then I make the connecting pipes, okay? When I boil it, then the boiling water or the steam, whatever it is, okay? It travels and now I make it pass through pipes. Okay, first let me complete the pipe on the other side also, and then I do it. So I have the pipe on the other side also, and through the pipe, the steam or the water, hot water will flow. Okay, now I make something blue, cool. Okay, something which is cool, we make blue. Something which is hot, we make red. So I have made it red, and now this is the radiator. Okay, so from here it goes, and now the pipe, the radiator pipe is moving like this, and it goes again like this, and now it comes and joins it. Okay, so now this zigzag pipe is a radiator. What's a radiator? Do you know what's a radiator? Let's see if you know it. If you don't know, no issue. Tell me I don't know, and I'll tell you. If you know, well and good. This is a radiator, the one thing inside the blue box. So what's a radiator? You must be knowing. I'm pretty sure about it. What's a radiator? Rishika, waiting for your answer. This is the last thing we are doing. Answer quickly so that I can proceed. What's a radiator? Okay, a thing that radiates or emits light or sound. You must have seen a radiator in your car, okay? Sometimes when we go on a long drive, and the engine gets a lot of heated, then the papa gets down from the car, opens the bonnet of the engine, okay, and he puts in coolant sometimes, okay. Those coolants, they cool the engine, they take in the heat from the engine. The radiator takes the heat from the engine and emits it to the atmosphere. You must have seen that the place where the engine of the car is placed, that's pretty hot once we come from a long drive, isn't it? It's emitting a lot of heat if you happen to sometime open the bonnet and go near it. Okay, so a radiator is something which is used for cooling. Okay, it takes away the heat from the body and radiates it to the atmosphere. Got it? So now what is going to happen to the water in the boiler, and what is going to happen to the water in the radiator? It's a simple common sense question. You use your common sense and you can answer me. What is going to happen to the water in the boiler, and what I've told you what a radiator is. Okay, so what is going to happen to the water in the boiler, and what is going to happen to the water in the radiator? Waiting for your answer. This is the last question for the day, and then I'll discuss this topic and finish it there. Okay, this is your last question. You must be thinking this fellow said that today is your birthday. I'll not pose too many questions to you, and now question after question is coming to me. Okay, so this is the last question for you. What happens to the water in the boiler, and what is happening to the water in the radiator? Very nice. In the boiler, it gets hot. That's correct. It starts boiling. And what happens to it in the radiator? Part 1 has been answered correctly by Rishika Jha. Congratulations, Rishika. Waiting for part B. What happens in the radiator to the water? If it becomes hot in the boiler, what should happen in the radiator? Come on, my smart girl, quickly. No, should I tell you? You're left with just 2 minutes. Okay, I'll tell you. I told you it is used to lose heat to the environment. Okay, so it is going to cool the water. It is going to take the heat from the water and radiate it to the environment. So the water is going to become cold over there. Okay, it's going to lose heat. Okay, so when I look at the circuit, okay, the boiler is similar to a battery. The boiler is similar to a battery or a cell. Okay, the boiler is similar to a battery because the boiler is giving heat energy to the water and the battery gives energy to charge. Okay, and the radiator is similar to a bulb. Okay, energy is lost in the form of I mean, it takes away energy and converts it into light energy. Similarly, the radiator is taking away heat and releasing it to the environment. Okay, so we'll continue from here. I hope you have understood something that gives energy in the circuit is the battery. The one which takes away energy and converts it into some other forms of energy is the load. In our case, in this case, it's the bulb. Okay, so the boiler is similar to a cell or a battery, and the radiator is similar to a component, an appliance, or a bulb. Right? Thank you very much. We'll continue from here. It was nice talking to you after so many days, and see you in the next week. I'm sure you must have a good birthday party. Okay, my wishes for you from my side. May you have a wonderful life ahead and become a very renowned person whom I could be proud of. Okay, chalo, bye bye. Signing off. See you next week.